Hey, what is up, welders? Welcome to Adventures in Welding. I'm Paul. This is episode number 43. What happened to episodes 41 and 42, you ask? They're coming. Hold your horses. They're special. Today in episode 43, we are going to break into a little bit of aluminum TIG welding. That's right. We're going to get the magic metal here, aluminum, 1/3 the weight of steel, almost quite as strong, and we're going to weld it. We're going to take the mystery out of it and show you it's just as simple as welding steel with the right settings on your machine. And speaking of machines, I'm welding today with the TIG 200 machine from our friends at Eastwood. This powerful 200 amp AC/DC TIG welder is ready for a variety of tasks, including aluminum. So let me get my gear on and let's get the welding going. Okay, there's no real mystery in welding aluminum. It welds just like any other metal. You get it hot, it melts, you add the proper filler metal to it to make up for what's melted, and add a little bit of strength, and you join two pieces. Now, one of the things you have to look out for is simply the preparation of your aluminum. Here's a piece of 6061 aluminum. It's about 1/8 of an inch thick. It's about 5 inches long, and about 2 inches wide. Now, the aluminum melts at about 1200 degrees. But the second raw aluminum comes in contact with oxygen, it forms aluminum oxide, which is second in hardness only to diamonds. And that aluminum oxide melts at about 3700 degrees. So while your torch may melt the aluminum underneath, on DC, it won't melt the oxides. And then you've got a mess on your hands. So you have to do two things. You've got to switch your machine over to AC if it's AC capable. If not, you're going to have to use a different machine. There are ways to weld aluminum with DC, but we're not going to get into that. This is simply absolute basics of welding aluminum. The second thing you're going to need to do is break up that aluminum oxide. And the simplest way to do that is with a stainless steel brush that is dedicated to aluminum. It touches no steel. See how I marked that? AL only, aluminum only. And just to make sure that it doesn't touch any steel, I'm going to lay the piece of aluminum that I'm going to prep on top of more pieces of aluminum. If you contaminate the aluminum with carbon steel, it's going to corrode. Okay? Keep that in mind. So now we'll just take our dedicated stainless steel brush and brush that surface to break up the aluminum oxide. Now I did half of this. Okay, you can see here, the bottom half has been brushed. See how it's dull and it looks like brushed metal? See how the top still has a little bit of a shine? You want to knock all that shine off and you want to get to that dull brushed metal. We're going to be using this Eastwood 200 amp TIG 200 AC/DC welder today with the 17 size air-cooled torch and a gas saver gas lens with a Pyrex cup on it. The gas saver gas lens are not necessary. What comes with the machine will work just fine, but this is simply my preference. Now, one of the main problems people have in welding aluminum is they're not really sure what their settings are going to be needed. Well, Eastwood has come up with this nice chart right on the top of your machine to show you what you need. So for 1/8 inch aluminum, it says on AC 90 to 140 amps using green, red, or purple tungsten. That's pure tungsten, thoriated, and I'm not sure what purple is. 3/32 tungsten diameter, 4043 filler metal, 3/32 filler, 0.4 pre-flow time, 6-second post flow, cup size, our gas flow rate, 17 cubic feet per hour, and the clearance effect, also known as cleaning, at -3 to 0. So if we come around to the front of our machine here, you can see the controls, and all we have to do is set them up for aluminum. Here's our amp control. Since I'm going to be using the foot pedal, we're not going to worry about it. Next we have the clearance effect, which is already set to -3. Pre-flow, I have it set to 0.6 seconds, just a little over half a second from the time you press the pedal to the time the arc starts, and a 5-second post-flow. Amp control set for the foot pedal, and the machine set for AC. So that's it for machine settings. This is pretty simple. The Eastwood TIG 200 is a great machine for welding aluminum. It eliminates a lot of what I call the gadgets. Frequency control, pulse. Those are nice things to have, but truth be told, they're not necessary. So you might even say, well, there's no digital amp readout on this machine. No, there's not. And it's not really necessary. You can't see it when you're welding. And the amp control is set at a range that is controlled by the foot pedal, unless you're using the trigger, in which case it's set right there, and you'll get what you get when you press the trigger. Now that can be useful for flash tacking, and we'll get into that in another video. But for now, this is a basic, simple aluminum setup, and it's ready to weld. You come over here and look at our gauges. They're all set up. Now I know that says 20 CFH, but when I step on the pedal, that's going to drop a little bit to just about 15, which is where I like it. Now we're all set up. Let's get ready and weld. It's brushed up, breaking up that aluminum oxide surface coating. But you want to make absolutely sure this metal is clean. As you can see right here, it's got a little bit of oil on it picked up from somewhere. Acetone or alcohol are what you want to use to clean it. So I'm going to wipe this down with an aluminum swab, with an alcohol swab. Wipe this one off too. Want to make sure you get all those oils and surface contaminants out of there. You want to be welding nice, clean metal. There's that metal I just brushed, and look what came off of it. Those are all contaminations on the surface. For good measure, I like to take my filler metal and give it a wipe also. No contaminations.
Alright, we're welding the aluminum here, and you can hear that sort of growling noise. That's just the alternating current, and that's exactly what it's supposed to sound like. Now, the technique used in welding aluminum is absolutely no different from the technique used to weld steel. The torch melts the base metal melts the filler. So the torch makes the puddle, you add a little filler, you move on. You wait for the puddle to swell, add filler, move on. Move, swell, fill, 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 and so on and so on.
Alright, there's our bead we just welded, and it looks pretty good. You can see the evenly spaced ripples. The crown is not too high. Puddle's a good size. And you see the white outline around the edges. That's where the cleaning has taken place. During the positive cycle of the AC cycle, where it switches between positive and negative 60 times a second, you get what's called cathodic bombardment. The ions break up the aluminum oxide on the surface of the aluminum, allowing you to get penetration in the DC portion of the cycle.
Alright, this time we're going to do a butt weld in the flat position. It's already been tacked, so I'm lighting up right on top of that first tack. I can't seem to get it to puddle here right at the beginning. I don't know why. And then I realized I need to step on the pedal more. I thought I had the pedal pretty much floored, but I don't. It just gets a little tight towards the end. I don't know if that's a issue with this particular type of pedal, or if it's just new and needs worked out a few times. But once I figured that out, right here in a second, I'm going to start moving. Anytime now. Come on, dum-dum, step on the pedal. Needs more heat. There we go. Once dum-dum figured out it needs more heat, we're moving right along here. Melt the two pieces, add the filler to the puddle, move along. Move, melt, add. Now I could have turned up the heat here considerably. The range was up to 140 amps. I'm doing this at about 100 amps. If I'd have turned it up to 140 amps, I could have moved a lot quicker through here, but I wanted to illustrate this process. Alright, we're coming over the last tack here. I'm just going to incorporate it into the weld. We get to the end, we add a little extra. There we go. Taper off and hold the torch in place until it times out.
You see the evenly spaced ripples. The crown is not too high. Now you notice here towards the end you need to let off the pedal more than I did, because there's nowhere for the heat to go. You see our cleaning zone. That's the white around the edge. And that, well friends, there's a very basic lesson in welding aluminum with the Eastwood TIG 200 AC/DC. That's a nice looking weld there, and that thing is not going anywhere. So if you've been welding steel for a while and you're in the mood for something different, give some aluminum AC welding a try. It's a lot of fun. Thanks for watching. Merry Christmas to you and yours, and I'll see you next time. This is Adventures in Welding.